Alright, so we're back. This is going to be a video about definite integrals, okay? So as a quick review from what we went over last time, we had the area is equal to this formula right here. The limit as n goes to infinity of the summation of f of I delta x times delta x. If you remember, this was the base of the rectangle, and then this was the height of the rectangle, so we were doing base times height, adding all the base times heights together for infinitely many rectangles, and then you would end up with the exact area underneath a curve. Now, this works for finding the area from 0 to b, but if you remember for our previous example, we went from 0 to b for the rectangles, but what if we were trying to find the area from a to b in which a is not equal to 0? Okay, so now you're looking at the area of a curve between a and b here, where it's not 0, it's in the middle of 0 and b. So how would you figure out this area? Well, what you could do is use the area equation up here, and then you just have to use it twice. So you'd find the area from 0 to a, so you'd find this area right here, and then you would find the area from the closed interval 0 to b, so you'd find the area from here to here, and then you would just subtract both of them. Okay, so you'd end up with something that looks like this, and I color-coded it. So the area from a to b is this green right here. If you can kind of see it, it's green for this part. Is equal to the area from 0 to b, the blue, so if you notice I colored in the blue from 0 to b, and then the area from 0 to a, I'm just subtracting off this little area right here to get this area. So I found the area from here to here, and here to here. I subtracted this part right here from the total to get this middle part. Okay? Now, this kind of leads us to our discussion about definite integrals. Before we went over indefinite integrals, which basically is just finding families of functions that represent the antiderivative of a certain function. Where if you take the derivative of an indefinite integral, you would get that original function that you started with. So indefinite integrals represented a possible antiderivative. Definite integrals will actually get you a number. And what number is that? Well, that's the area that was between the endpoints a and b. So we have this area right here. Now the thing that I want you to notice is before when we were trying to find derivatives, we were taking the difference of y divided by the difference of x, so dy over dx. Here we're adding up the function and multiplying it by d of x. So rather than dividing by the difference, we're adding up the product of this f of x, this f of I delta x and d of x, dx right here. So it's kind of the opposite, and that's kind of what I want you to see by doing this. And that kind of leads us to, instead of being the derivative, we're doing the opposite, which is the antiderivative. And that's what I'm showing right here. Okay, this is what's considered a definite integral. We're going from a to b, f of x times dx here, is equal to this area formula right here. So this is tying the area formula being equal to the antiderivative, only this time it's with endpoints. Rather than being a function, it's going to be a number. And how do you figure this out? Well, you take the antiderivative of this function and you plug in b. So you plug in that one endpoint b here and you subtract it from the antiderivative of this a endpoint right here, and then you'll end up with the area from a to b. If you notice, this formula right here looks really similar to this formula right here because they're related. Okay, the area from 0 to b is the same thing as finding the antiderivative at endpoint b. It's finding the area from 0 to b. So we're just subtracting these two like we're subtracting the areas up here, and that's an easier way of finding the area underneath a curve. Rather than having to use this formula, you can just use the antiderivative and then make it a definite integral rather than indefinite by subtracting off the values for each endpoint. So you'd plug in the b to the antiderivative and subtract it from the a that's plugged into the antiderivative, and you would have the area under that curve. Okay, so that's definite integrals. If you have any questions about this video, let me know.